Hi there. So Hawks does some nice videos with this lesson, but I know it's a more challenging one, so I thought I'd go ahead and make a video. It has, it's a pretty long video. I've got a lot of different examples. Maybe I'll catch some that they didn't do. Maybe I'll do it a different way. Hopefully it'll help. You feel free to fast forward to what you need. I might do too many examples for you. Okay, so let's start off with this one. It says the sum of two numbers is 58 and their difference is 12. So we have these two numbers, and for lack of any other, for a good reason, I'll just go ahead and use x and y as my variables. So x is going to be the first number, and y is going to be the second number. Now, you've been working with systems of equations, so that's why I'm always going to end up with two variables when I do these problems. So it says the sum of the two numbers is 58, so that means I'm going to add them, and it should equal 58. And then my second equation is going to come from the next statement where it says their difference is 12. So I'm going to take x minus y, and it's going to equal 12. Now, by doing that, I've sort of forced x to be the bigger number, but I don't think that really matters. Now, you've learned to graph systems of equations to solve them. You've done substitution, and you've done some addition or elimination with them. In this one, it looks like it's beautifully set up for elimination because the y's will just cancel out. And so I'm left with a 2x. And then if I add the 58 and the 12, I get 70. Divide by 2. I've got my first number must be a 35. Now, once you get your one of the answers, then you can go ahead and plug it into either of the previous ones. And since that's an x, we can plug it in right there. I could plug it into the bottom one as well. I guess I'll go ahead and just plug it into the top one there. And so 35 plus y is equal to 58. And then I solve for y by moving the 35 to the other side. So my second number must end up being 23. All right, so there's an example of a number problem. Here's a second type of number problem. It's still the same deal where you have two numbers. So let's go ahead and say x again is the first number, and y is going to be the second number. The sum of the two numbers is 43. All right, so again, I'm going to come up here. X plus y is going to be 43. But this second the second statement's a little trickier. It says the sum of the smaller and 6 times the larger is 183. Okay, so I'm still going to be adding them because it says the sum of the smaller. I don't know which one's the smaller, but it doesn't really matter. By writing my equation, that will sort of dictate it. I guess I'm going to let the smaller just be x. And 6 times the larger. So then I would have to take 6 times y. And that's going to equal 183. I again would probably do elimination, but I'm going to take the bottom equation, or maybe the top equation, doesn't really matter again. Just choose and multiply everything times -1. So that's going to make that be a negative x and a negative y and a negative 43. By doing that, the x's will now cancel. I have a negative, it's assumed to be like a 1y. So negative 1y and a positive 6y would leave me with 5y. And a 183 that's positive with a negative a negative 43. When I combine those, I'll end up at 140. Divide by 5. And I end up at 28. And now y happens to be the larger one. Remember, because it was 6 times the larger. So when it said 6 times the larger, I was dictating the y to be the larger. So when you enter this, they may specify in Hawks that they want what's the smaller number, what's the larger number. Well, y was our larger number. And then again, we can just plug it in somewhere to find the second answer. Perhaps I'll go ahead and I'm going to throw it into the original, but I'm going to throw it in before I put the negatives on everything. So it's going to be x plus 28 equals 43. And then if you move the 28 to the other side, I get 15 for the smaller number. All right, let's move on. Here's a problem, a distance problem. I have a couple of these because there's different types of them, and maybe the more you see it, I guess, the easier it will get. What you need to recognize for these problems is that you are going to be using your distance formula. And the distance is always equal to the rate times the time. But I typically have a couple different scenarios going on, so I'll end up doing the distance equals rate times time twice. I know on Hawk's videos, they kind of make this big chart. If you like the chart, you can do the chart. I guess I'm trying it to show you another way in case that didn't click for you. So I'm just going to use this formula, distance equals rate times time. It says Kenneth made a business trip of 222 miles. He averaged 60 miles per hour for the first part of the trip and 48 miles per hour for the second part. Okay, so we're going to have two scenarios, the first part of the trip and the second part of the trip. So the first part, I'm going to do distance equals rate times time. And over here, this is going to be the second part. I'm going to do, and let me clarify that it has nothing to do with where I'm at on that sentence. So this is just the second part. I'm just doing it over here on the right. This one over here is the first part of the trip, first part of the trip. So I know the rate for both of those. But the rest of it is a little trickier. He made a business trip of 222 miles. So the first part of the trip might have been 200 miles and the second part been 22 miles. I don't know how that's split up. So the first part, I'm just going to say, I don't know, it's D. That's the distance. I don't know what it was. The rate, though, I know is 60. And then the trip took a total of 4 hours. So again, I don't really know at this point how long the first part took. It might have been 3 hours, and then the second part took 1 hour. I don't know, so I'm just going to call it T. There's your two variables that we're going to end up dealing with, the D and the T. Okay, so let's talk about the second part of this trip. On the first part, I just put a D for distance. Remember I said, well, if it was 200 miles, then the second part could be 22 miles. All I did there was in my head, I did some quick math of 222 minus what we did on the first part, which was, I was saying 200. Ultimately, if you take 222 and subtract how long, or how far, I guess, you went on the first part of the trip, which was D, then that would be how much was the distance was left for the second part of the trip. All right, the rate was given to us at 48, so that's easier. And then the time is tricky again. The first part of the trip, I said, took T hours. The second part of the trip is going to be 4 hours minus whatever that first part took. So 4 minus T. That second equation is way, way messier. I do think that this one would be set up better to do substitution rather than doing the elimination or the addition that I was doing on the previous problems. So set up beautifully for substitution, because right here I know that D is equal to 60T. So I'm going to substitute that in for D over here. All right, now let's rewrite this sentence with that, or that equation with that 60T substituted in. Don't mean to be OCD here, but got to go with a blue pen. All right, so 222 minus, and instead of a D, I'm going to put 60T equals, and then I'm going to distribute 48 times 4 is 192 minus, and then distribute again 48 times T. Notice that I've eliminated the D here, and I just have T's. I'm going to get the T's together on the same side, so I'm going to add this 60T over here. So I have 222 equals 192, and a 60, positive 60 with a negative 48 is going to get me a positive 12T. And since I moved my T's to the right, I'm going to take my numbers to the left so I can get them on the other side. that ends up being 30 equals 12t, and then divide by 12. This does not come out nice. It's not terrible, but it's just not a perfect answer. So it'd be 2.5 is what that reduces to. So that means that the time, t, was the time over here that it took the first part of the trip. It took 2.5 hours. If I want to know how long, it says, how long did he travel at each rate? So 2.5 hours on the first part of the trip. And then if I take 4 minus 2.5 hours, I get 1.5. So the second part of the trip is going to be 1.5 hours. Let's try another distance problem. It's just set up a little bit differently, but I thought I'd go through another one. Alice travels 4 times as fast as Gloria. Traveling in opposite directions, they are 280 miles apart after 8 hours. Find their rates of travel. All right, so they're traveling opposite directions, but they don't necessarily go the same distance but we know that the grand total of it is going to have to be 280 miles. As I set this up, instead of having like a first part of the trip, the second part of the trip, I have 2 different people. I have Alice and Gloria. So I will still use my distance equals rate times time formula for us. That's a formula we will definitely be using in this. So I kind of don't, do I want to start with Alice or do I want to start with Gloria? And I think because of the way that first sentence is, it says Alice travels 4 times as fast as Gloria. We're kind of basing everything off of Gloria, it would appear. So I'm going to do Gloria first. So Gloria is distance, don't really know. Her rate, don't really know. But her time was 8 hours. They both were traveling that full 8 hours. So I'll put in an 8 for the time. Now we look at Alice. And again, it's going to be distance equals rate times time. But now we're going to base everything kind of on a comparison back to Gloria. She travels 4 times as fast, so that's going to be her rate. But let's talk about her distance. Remember that the total distance is 280. So I'm going to assume then that if I take 280 and I subtract the distance that Gloria went, that's going to be Alice's distance. The rate that she went was 4 times as fast as Gloria, so 4 times R. And then she also was traveling for the full 8 hours. Again, okay, so after this, it sets up pretty similarly. I'm going to do that whole thing where I'm going to substitute again. I'm going to put that in for the D right here. I'm going to end up at 280 minus, and instead of a D, it's an R times 8. I'd probably call that 8R equals, and on this, I'm multiplying, so I'm going to go ahead and multiply those numbers. That's a 32 times that R. Add the 8R to the other side. 280 is equal to 40R. Divide by 40, and R is actually 7. So R is the rate. That's the rate she was traveling. And that would have been Gloria's rate. And then Alice, remember, went 4 times as fast. So 4 times 7 would be 28. So Alice was 28 miles per hour. I'm guessing they're not driving. I don't know what this is. Bike rides, maybe? I don't know. All right, let's move on. Our next problem is on a shape, and it deals with the perimeter of a rectangle. You do need to know the perimeter formula then of a rectangle, and the perimeter is just the distance around, so you're just adding up all the sides. But since it's a rectangle, the sides match, so you'll have 2 legs that are, we call them the length, so 2L, and then add in 2 widths, and that would be the total perimeter all the way around. Now, in this particular problem, they actually tell us what the perimeter is. So instead of putting a P there, I could put a 176. That is the perimeter. And you can see then here is one of the equations. It has an L and it has a W for your length and for your width. We have one more piece of information. It tells us that the length of the rectangle is 6 more than the width. I like to write an equation based just like taking these words and just turning them into symbols into an equation. The length of the rectangle, that's going to be L, means equals. 6 more than means I would have to add the width. 6 more than the width. All right, so I would have the length is 6 more than the width. So I have the width, but it's 6 more than the width, like that. Now, if you had written that 6 plus W, that would be okay, but you have to be a little bit careful because it would matter if it was subtraction. We would put the width and then it's 6 more than that. And this problem looks like it is set up beautifully, again, for substitution. I'm going to take that W plus 6 and plug it in for the L. You're going to distribute. Over here on the right side, you actually have a couple terms that are like terms. Why can't we just go ahead and combine this 2W with this 2W? And together that would be a 4W. Move the 12 to the other side. And then divide by 4. Looks like the width is going to be 41. And what are we measuring in? This is in inches. So the width is 41 inches. And remember that the length was 6 more than the width. So then our length would be 47 inches. All right, let's keep going. All right, here's an age problem. There's so many different types. I've still got like 3 more problems to do. There's so many types of these. Okay, Travis is 19 years older than his sister Danielle. In 14 years, he'll be twice as old as Danielle. How old is each of them now? All right, so I guess their ages. Well, shall we use a D for Danielle and a T for Travis? And Travis is, and let's do kind of like what we did last time, where you kind of turn that just into a sentence. Travis, so T is means equals. Travis is 19 years older than his sister Danielle. So whatever Danielle is, I'm going to add 19 to it. Then we have another sentence here. In 14 years, he'll be twice as old as Danielle. Okay, now that's a little trickier of a problem. What I would do on this is I go back to the T. T is Travis's age right now. So in 14 years, Travis will be T plus 14. And so in 14 years, he will be, so that's going to equal twice as old as Danielle. Twice means take it times 2. So it's twice as old as Danielle. But remember that in 14 years, Danielle's going to be older too. She's going to be 14 years older. So it's not 2D, it's 2 times how old Danielle will be at that time, which is her age plus 14. All right, that's definitely a wormier problem. We got T and D in both of those. Let's go ahead and do that substitution because it looks like it's set up very nicely for that. So I'm going to have D plus 19 plus 14 equals, and then I'm going to go ahead and distribute here, 2D plus 28. Just like last time, we have some like terms that we could combine to simplify this equation up. So 19 and 14 added together is, what is that, 33? And over here, there are no like terms, so I'll leave it 2D plus 28. Let's get the D's together. So I'm going to subtract this D over here to this side with that D. And remember, that's like a 1D. So 2D minus 1D is a 1D. And really, you could probably just write it D. You don't need to write it 1D. In fact, Hawks doesn't really like it when you do that. So I will get rid of that 1 on my next step. So that's 5 is equal to D. So Danielle must be 5 years old. And if Danielle is 5 years old, you could plug that back in. Maybe right here is the easiest place. And so Travis will be 24 then. So Danielle is 5 years old. Travis is 19 years old. And this is another one that you might be able to just check. You could check your answer. Let's think about it for a second. It says in 14 years, okay, so if you take Travis, he's, oh, where did I get, did you catch that? He is not 19. You plug 5 in for D, and that would make it 24 years old. He's 24. Okay, so in 14 years, what would he be? In 14 years, he'd be 38, and in 14 years, Danielle would be 19, and that is twice of Danielle's age. Okay, just checking, making sure my answer made sense. All right, this is a work type of problem where we're setting up a scenario of people working and their wages and how that works. So it says Brian is working his way through school. He works 2 part-time jobs for a total of 23 hours a week. Job A is $6 an hour. Job B is $6.90 per hour. How many hours did he work at each job if he made a total of $146.10? All right, got it. So I've got job A and I've got job B. Shall we let A be the number of hours at the first job, I guess. And B is going to be the number of hours at the second job. He works 2 part-time jobs for a total of 23 hours. So between the A and the B, together that has to add up to 23 hours total. So there's one of our equations. A plus B is going to have to equal 23 hours. And then the next equation is a little messier. It's going to talk about money. Job A earns him $6 for each hour. So to see how much money he made at job A, I would do 6 times A. That's how much money he made at that job. And job B pays $6.90 for each hour. So then I'm going to add to this because he made $6.90 for every hour that he was at job B. So $6.90 B. But we know that he made a grand total of, I'm running out of room here, $146.10. Sorry, so messy. Okay. Now this is one where you could set this up and do some elimination, or you could do substitution. I don't know. I guess I kind of like substitution for it. It's not quite as perfect of substitution, so I thought I'd show you an example here where you have to do some solving to get this substitution. I need to get this A or B. This equation I'm going to work with because it's simpler. I'm going to get this A or B by itself, so I'm going to go ahead and just subtract B to the other side. So I have A equals 23 minus B. And I'm going to take this right here and substitute it in for A in the other equation. But I had to get that A by itself first. Remember doing that with substitution? Here's my new equation then. I'm going to have a 6. And instead of an A, I'm going to put in 23 minus B plus 6.90B equals $146.10, like that. Now you can see in my equation, I only have a B. That's good. Let's distribute and see what we end up with. I think that's 138, but I better check. All right, so when I distribute, I get 138 minus 6B plus 6.90b equals 146.10. And again, you always want to look to kind of clean up one of the sides. This side right here for sure would clean up. There's nothing to do over here, but these b's could clean up and get together. You have a -6 with a positive 6.90. If you think of that money, it's like you had -$6 and a positive $6.90. I'm going to be left with 90 cents. So it's going to be a 138 plus 0.90b equals 146.10. Subtract the 138 to the other side. And I get 8, it's an 8.1. If you're thinking money, that'd be $8.10. You can put the 0 or not. I'm going to come back and I'm going to divide by 90 cents. And it comes up nice to 9. All right. So B is equal to 9. That means he worked 9 hours at job B. Probably grab that and go put it right here. You could put it into the top one also, either way, but I'm going to do 23 minus 9. I end up with 14 hours then at job A. Whew, I got one more. Are you still with me? Okay, here it is. This is a working with coins type of problem. So you have $4.40 worth of change in nickels and in dimes. All right, we have 2 times as many nickels as we do dimes. How many of each type do we have? All right, so here's the thing. I'm going to let N represent the number of nickels. And we'll let D represent the number of dimes. If we have $4.40, what you have to acknowledge, and this is just something you have to know, it doesn't say it in here, you have to recognize that a nickel is worth 5 cents. So the value of all those nickels would be 0.05 times however many nickels you have. So 0.05 N would represent how much money you have in nickels. Plus, you can do the same thing with your dimes. The dimes are 10 cents each, so if I took 10 cents times every dime, that would tell me how much money I have in dimes. And that would equal the total amount of money I have, which is $4.40. The next equation, it says she has 2 times as many nickels as dimes. So she has way more nickels than she does dimes. Let's even look at a specific scenario. If she has twice as many nickels, that means she might have 60 nickels and then she'd only have 30 dimes. So if you look at that, if you're going to try to do a comparison between the nickels and the dimes, I would have to double this number here to make it equal that number. So I need to double the dimes to make it equal how many nickels there are. So the nickels would be equal to 2 times the number of dimes. This is then a beautiful substitution type of equation. Instead of the N, I'm going to put a 2D in there. Okay, if you have 5 cents, I'm going to take it times 2D, so that's going to end up 0.10D plus 0.10D equals 440. I don't know, I keep using D's. They look a lot like my zeros. I apologize. So I have 10 cents times D plus another 10 cents times D would get me 20 cents times D. And then I'm going to divide by 20 cents. And the number of dimes, let's see, 20 cents would go in there 22 times. So that means I have 22 dimes. To find out how many nickels, I can plug it into either of those other equations. I suppose it would be simplest to plug it in right there. So I have twice as many nickels. So the number of nickels I would have would be 44. And again, you can always check that just in my calculator real quick. I'm going to take 44 times 5 cents. Okay, so that's $2.20. And this is me just checking my work here. $2.20 in nickels. And then I could take 22 times 10 cents, which maybe you can do that in your head. That's going to be $2.20 also, but added together. So coincidentally, you have the same amount of money with both of those, which I guess sort of makes sense because the 5 cents is, or the 10 cents is twice the 5 cents. Okay, whatever. All right, I'm finally done. All right, hope it helped you. Bye.